Okay, good morning everyone. So myself Deobrata Kumar Das from Dumka Engineering College. Today we will take control system.
Am I audible? Please respond me anyone. Am I audible or not?
Yes, sir, you're audible.
Okay. Okay, so let's start. So last class we have also discussed the root locus method, and we have discussed different procedure and different features of the root locus method, and also we have solved the one single problem in the root locus method. So today we also another examples we have to discuss. So is the root locus method. Example. So you have to given this type of question. Sketch the root locus for the open loop transfer function of a unity feedback unity feedback control system given below and determine number one, the value of k for zeta is equal to 0.5, and number two, the value of k for marginal stability, and number three, the value of k at s equal to -4 and obtain the closed loop transfer function for the value k is equal to 1.66, and given equation, that is gs, this is equal to k by s into s plus 1 into s plus 3. Okay, so this type of problems you have to given in your root locus method. First, we have to read the questions. I sketch the root locus for the open loop transfer functions for a unity feedback. That means here HS, that is the feedback factor. This is equal to unity, that means 1. And system is given below, and you have to determine, these are the three questions, when the value of k, the zeta is 0.5, and the value of k is marginally stable, and number 3, the value of k is when s equal to, that is minus 4. We have to obtain the closed loop transfer function when the value of k is 1.6, and you have to given the characteristic equations. This is equals to gs equals to k by s into s plus 1 into s plus 3. So what have to do? We have to follow the rules. Previous classes we have to discuss what is the basic procedure one by one. So number one, first we have to locate the root. So the root loci start, we know that the value of k is equal to 0. And what is the root? That is the s. That means first is s is equal to 0. Then s plus 1. That means s equal to minus 1. And then s plus 3. That means s equals to minus 3. These are the basically root loci of the region of the state of the plane. So this is s for that is equals to 0, s plus 1, that means s equal to minus 1, s plus 3, that is equal to s equal to minus 3. Okay. Then number two, we have to discuss according to our procedure, according to our rules. There is no open loop 0 so the root loci terminate the at infinity. Okay. Next step is we have to calculate number of poles and number of zero is present in this equation. So we know that. So these are the basically pole. So number of pole is here, that is 3. That means 0, minus 1 and minus 3. So the pole, that is P, we have to know, that is P equals to 3. And here 0 is also, that is only K, and others remaining it is not present. That means 0, that is Z. We have to express the 0 is Z, that is equals to 0. And we know that every problem, more or less, we have to see the pole, number of poles is greater than the number of zeros. Then the system is also basically it is present on the root locus region. And we have to know, then we have to calculate what is the number of branches. We have to know, so number of branch, we express here n, and n it is the value, it is same to the number of poles. So therefore, number of branches, it to not okay, sorry for that. My here network is unstable, so that's why the link is cutting again and again. So I think all of you question it is also remembered. So just I am recalling the answers also. So first we have to calculate the root locus. That means the root loci start, that is equals to k equals to 0, and we know that the pole is s equal to 0 and also s equal to -1, and last one it is s equal to -3. Number 2 we have discussed, as there is open loop 0, the root loci terminate at infinity. And number 3 we have discussed previously, that is number of pole here also 3. We have to express the number of pole p, and number of 0, it is in this question, that is also 0. And we know that more or less number of poles, it is greater than the number of 0, that is pole greater than 0. So therefore number of branches of the root locus this is n equal to 3. So we know that number of branches we have to express here n, capital N, and this is also same to same number of the pole also. Then number 4 we have to apply the number 4 rules. This root locus on the real axis, sorry, on the real axis exists between that is s equal to 0 and s equal to -1, and beyond this is the maximum, that is s equal to -3. We know that these are the basically 3 poles we have to calculate it from here. Okay, next number 5 we have to calculate the characteristics equation and also a break even point also. Okay, so the between open loop transfer function, open loop poles, here we have to imagine that is s equal to 0 and s equal to -1. So this is s equal to 0 and s equal to -1. There exists a breakaway point as calculated below, So the characteristics equation is, that is also s into s plus 1 into s plus 3 is equal to, sorry, it is plus, that is also k, this is equals to 0. So we know the equation I am written here. This is gs equals to, sorry, k by s into s plus 1 and s plus 3. So these are the basically given questions, that is a given characteristic equation. So now these are the basically characteristic equations. This is s into s plus 1 into s plus 3 plus k, that is equals to 0. So we have to calculate these equations. So this equation, it is coming, you have to multiply this one to this one, again this result to this one. So the final result is given, that is s to the power cube, then 4 square, 4 square plus 3s, then plus k, that is equals to 0. Or we have to written this equation, this is k equals to, this is minus of s to the power 3 plus 4s square plus 3s. You have to written this equation. Then you have to derivative, that is a first order derivative with respect to the s. So that means dk ds, that means dds of k. This is also first order derivative. Sorry, this is square, I think. Q, we apply the rules, that is ns to the power n minus 1. This is n s to the power n minus 1. So we have to derivative that this one also. This is, I think, 8s is coming and constant, that is 3. Again, we have to put the value, we have to know, that is put dk or ds, that is equals to 0. So when this is 0, that means this is equals to the 0. So we have to return the equations. This one, I think this is coming 3a squared plus 8s plus 3. This is equals to 0. Okay. So then you have to calculate the roots. So I think this is a not middle term factor, because 3 into 3 9 minus 1, this is 8 is coming, but one sign it is not accommodated common part. So in that case you have to apply the rules, minus b plus minus b square root over of b square minus 43 by 2a, you have to apply the rules. So I think the root is coming, that is s equal to minus 1.33. Everyone please calculate in your rooms. So value is coming this one. These are the plus minus. That means the two roots are present here. One we have to express here s1. This s1, this is equals to minus 0.45, and another it is also this one, that is minus 2.21. Sorry, 2.21. You have to calculate minus 1.33 plus 0.88. So these are the basically coming this one, and another one minus 1.33 minus of 0.88. The result is coming this one. So these are the basically 2 point we have to locate it in our Locus method. Next, so the break-even point. So we have to return the break-away point has to lie between, that is s equals to 0 and s equals to minus 1. Okay. So the break-away point again, the link is network is gone, so the link is off. So we have to point the break even point. That's the break away point. Point is that is s equals to minus 0.45. So this is the basically break even point or break away point in the state of the region. Then we have to calculate number 6. What is the number 6? It is I think angle of asymptotes we have to calculate it. Okay. So the angle of asymptotes is given by, so we have to know the rules, that is the formula, that is also the 2k plus 1 into 180 degree by pole minus z, that is pole minus 0, where the value of k we have to put first 0, then 1 and 2 and so on. So you have to put the value again, k is equal to 0, then 2, 1, then 2. So the three asymptotes are at any angle of, number 1, we have to put when k equals to 0 in this equation. So I think 2 into 0 plus 1 into 180 degree divided by, you know that number of pole, that is 3, we know that number of 0, it is also 0. So you have to calculate it. So 0 plus 1, that is the 180 degree by 3. 180 degree by 3, that means 60 degree is coming. Okay. Number 2, when k is equal to, that is 1. So I think the value is coming 2 into 1 plus 1 into 180 degree divided by pole minus 0. That means 3 minus 0. So the value is coming, I think 2 into 2 plus 3. 3 into 180 degree by 3. That means the 180 degree is coming, I think. Okay. Is it clear, all of you?
Yes, sir.
Okay. Next, you have to put the k is equal to 2. That means 2 into 2 plus 1 into 180 degree divided by pole minus 0. That means 3 minus 0. So 2 into 2, 4. 4 plus 1, 5. 5 into 180 degree divided by 3. That is 60. 60 into 5. I mean that is 300 degree asymptotes is coming. So these are the basic 3 asymptotes angle we have to locate in the maps. That is a root locus method or maps. This number 6. So number 6 we have to calculate angle of asymptotes. Then number 6. Sorry, number 7. Number 6 we have to calculate it. Number 3 we have to calculate the intersect point. That means the 3 asymptotes intersect on the real axis at, so what is the rules we have to know? That is, we have to express intersect point, that is x. This is equals to, I know that is summation of poles minus summation of 0 divided by pole minus 0. So this is the basic rules you have to when you have to calculate the intersect point of the three asymptotes point on the real axis. So we know the value. So pole is in our problem it is pole, it is also 3, first 0, then summation, that means plus, but pole is present, we know that one is 0, -1 and -3. So we have to summation this point. So result is coming, I think, this one. And number of 0, we know that that is also 0. This is again pole is 3, 0 is z is 0. So you have to calculate this value. I think the value is coming, that is minus of 1.33, because minus 4 by 3, minus 4 by 3 you have to calculate it. These are the basic comings. So now, what is the basic root locus graphical method? So now we have to try to the diagram that point. This is the real axis. Another one. This is the imaginary axis. So this is the first center point where the value is k is equal to 0. Okay. Another. This is the also another one, another number 2. This is the number 3. This is the number 4, and so on. And this is the value of the continuing the imaginary axis. This is the breaking point. We know that. That means here value is k is equal to infinite. This is -4. This is the -3. We know that. That is the -2. This is the also -1. Okay. So and this is the basically imaginary axis where we have to calculate it. This is the J1. This is also another one down part. This is the negative region, minus J1, and so on. This process is continuing. This is the minus J2. This is the another one, minus J2, and so on. So what is the intersect point? That is a break-even point. We have to calculate it previously, 0.45. So 0.45, just you have to imagine that is a halving point. That is this point also. This is the value of 0.45. This 0.45, this is basically the break-even point or break-away point. So, and then you have to calculate another one. It is also value we have to plain calculate it. This is the s equal to -3. S equal to 1 minus 1 minute. My whiteboard, it is hangover. Just wait. Okay. So we have to previously calculated the state of the plane at the break-even point, that is s equals to minus of 1. Sorry for that, today class. It is very disturbing for network issue from my ear. That is a college premises. So again, the class is cutting down. So this problem we have to solve. I am uploaded the Google Classroom portal. So please, all of you, please see it carefully also, because the diagram I am written here totally it is erased. So sorry for that. Okay. So everyone, please write your own name and roll number in the chat box also. And this problem I am solving and then upload your Google Classroom portal. So all of you please see the Google Classroom portal. Then it is any questions or any doubts, so please ask me another one classes also. And please, all of you, please solve the different types of problems in this regarding method of root locus method from the books, available books in your hand, that is B.S. Manke, linear control system, or Nagrat Gopal, or any sources of the books. Okay, so I conclude today class also because network is unstable. So again and again it is network it is down. So please everyone write your own name and roll number in the chat box also. And Gautam is present. Please respond me. Not present. Okay, Vikas Kumar Mahato, please respond me. Vikas, are you hear me? Vikas, are you hear me? Okay, Songita Marandi, please respond me.
Yes, sir.
So please you take a screenshot of the participant list and after ending the class you have to send me. Okay. Okay, so everyone please write your own name and roll number in the chat box also. So I today class we have to concluded. So again, new classes we have to discuss another examples and you have to follow the Google Classroom portal also for the class notes also. Okay. Thanks everyone.